All right, we're going to keep going on our journey around the sun. Remember what I kind of ended our last video with is what right ascension and declination mean. If we were to project the grid system that is latitude and longitude on planet Earth, project them out into the sky, we'd have a grid system, and the grid system corresponds to the same thing. So if you're north or south of the equator on planet Earth, you have positive and negative latitudes up to 90. Same thing is true with something called declination. If you are north or south of the celestial equator, you have a positive or negative declination to tell you what that location is. The one that corresponds to longitude is called right ascension. Okay, right ascension then has to start somewhere and just goes all the way around the sky, the same way longitudes go all the way around the planet Earth. Got to start somewhere. So where they ended up picking is one of two locations where the celestial equator and the ecliptic intersect. All right. Happens to be the one I have over here, and I'll define it for you here in a bit. But please remember, right ascension is just degrees. The only difference is of a circle, degrees of a full circle. The only difference is they don't communicate it in degrees, so it's not between 0 and 360. What they communicate that angle in is hours, minutes, seconds. So remember, a full circle around the Earth, you have 24 time zones, right? So remember, we said if we take 360 and divide it by 24, you're at 15. There are 15 degrees of a circle for every hour. And that's what I want you to remember. There are hours, 24 of them, that make up a circle, and an hour is made up of 15 degrees, okay? But just remember, there are hours of angles. So instead of saying we're at 15 degrees longitude, what we would say is we are at a right ascension of 1. And instead of saying we're at 30 degrees longitude, we're at a right ascension of 2 in the celestial sphere, okay? Those right ascension numbers I wrote on the whiteboard, and it may be hard to see, but where this intersection is the right ascension is 0, which also corresponds to 24. And then as we go in this direction, we have a right ascension of 1. So this could be the first right ascension number. This is a right ascension 2, 3, and it would keep going all the way around the classroom. And what you end up seeing there is, remember, is the Earth continues its journey around the sun. Now we're into the month of December. Certain items in the sky here will have a right ascension of dancing around 6 hours, because again, we're 1/4 of the way around, and this is 1/4 of 24. And as we keep going, we'll get through the winter and eventually end up back to springtime. Remember, there's March, looking in that orientation. And if you can tell, it'll be fairly difficult to see, but way over here, I have the right ascension of 12, which means it's the exact opposite part of the sky, which ought to make sense. It's the other place where those two lines intersect. So we'll go 13, 14, 15, 16, 17, 18, then is 3/4 of the way as we keep going. Remember, here is when we mentioned the month of June. And you can see it's written there. So this would be 18, because now we're 3/4 of the way there. And as we continue in the journey, we'll end up back where we were there. So what we're learning is different seasons can be associated with different right ascensions and declinations in those particular constellations that we'll learn about in a bit. Will have different right ascensions. Seasonal declinations then just mean north-south. Okay, so just think of a full circle. It's 24 hours. All right. Now, This is, again, the month of September. The only reason I'm starting with this one is because it happens to be closer to the camera, and you can see this in that whiteboard more easily than you could the one on the far side there that I was alluding to as I was walking around. As we're going again from June, this is then, the winter months, and where I'm at right now is walking towards autumn. This is the first autumn month, right? That's September 21st. We call a autumnal equinox. You should already recognize this is the beginning of an equinox. Sometimes they're getting away from calling them autumnal because it's only beginning autumn in the northern hemisphere. It's beginning spring in the summer, or I'm sorry, in the southern hemisphere. So sometimes they'll just call it the September equinox. Okay? That is occurring when you can see in the background here, the celestial equator is a location on the ecliptic. As the Earth is orbiting in its orbit, it's going this way. When the Earth hits that location along the ecliptic line, that's when we define that as being the autumn or September equinox, okay? When the Earth hits that location. But here's an interesting thing, though. Remember, the joke phrase I use is the Earth didn't always move. What that means is, for thousands of years, people believed the Earth was not moving and everything orbited around it. So even though the Earth is at the location along the Earth's orbit, that's not what we were using as the definition of the first day of autumn in the northern hemisphere. What we were focusing on is, what is the sun doing as it makes its journey around the Earth? Okay, so what I want you to associate with the orientation of this in September is, where is the sun along the ecliptic? And to answer that question, I'm going to move the perspective of the camera here, and hopefully it doesn't stop working, because sometimes when I move the camera, it doesn't like to be moved. I'm going to rotate it, and hopefully it continues to work here. As I rotate that camera, I will show you the perspective of an observer on planet Earth looking back towards the sun. See that? There's the sun there. And I'm going to line it up with where we are here. And as we see I'm going to keep going here. Hopefully it works. I'm putting us near where the sun is. See how the sun is lined up with that far whiteboard? And you can still kind of see up here what that is kind of that little fake beard for Mickey Mouse I have right there, and there's a pencil sharpener. But the sun is located in that far whiteboard. All right, and I will again go back to showing you that far whiteboard where the sun isn't quite in the way. In that far whiteboard, I have the same thing, celestial equator there and ecliptic, and the sun is going to hit that spot in the sky. When the sun hits that spot in the sky is where the original definition came from in terms of the September equinox. Is the sun is moving across the sky, boom, it hits that location. When the sun rises is what I want you to think about specifically. When the sun rises in that location, what day is it? Because remember, folks on Earth, right? Folks on Earth are going to experience a sunrise as the Earth rotates this way. This person is now going to look towards the sun when it's rising. You can see the constellations that the sun is located in, that as the sun rises, the sun will obviously drown out those background constellations. But right at the instant that the sun comes over the horizon, the background constellation that it is in is a significant one. And for this particular time of year, that's going to be Libra. All right. So I want you to associate a fall, a September equinox, as the sun being in Libra. Okay. Not that it's a big deal, but it is when the sun crosses the location where the celestial equator and ecliptic meet. All right. Makes sense? That location over there is the beginning of fall, even though it's the exact opposite side of the orbit. That location, when the sun is over there, is fall. All right. So this particular whiteboard, I'm going to keep rotating this again back to where we were. This whiteboard with the beard in the background, pencil sharpener, whatever. This is September, so I will write it even bigger so you can hopefully see it. Okay, and this constellation is Libra. Right there, where that big heavy dot is, happens to be in the constellation Libra. So hopefully you can read that. I know it's a little bit distant. Oh yeah, you can read that. Good, that's September. Now again, even though, look here, see where I have this written on the books? This says March. Okay, that's where the planet Earth would be as it's moving around the sun. But we're again focusing on what constellation does the sun appear to rise in, or doesn't appear, it does rise in, on that morning when it crosses that line, where it's in that location where the ecliptic and the celestial equator intersect. Okay, that's there. So the autumn equinox, the September equinox, is when the sun is in constellation Libra. The planet Earth happens to be crossing it on the opposite side, the other location where the celestial equator and ecliptic intersect. But again, kind of doesn't really matter where the Earth is, because at the time they were following the sun across the sky. All right.